Hi everyone, let's start lecture 2, which is chapter 5 of our textbook, and it will be about inventory control with uncertain demand. And this chapter will be covered in 3 sections in 3 weeks. So this is the section 1, and this is the first part of section 1. On the course map, we have completed chapter 4, which was about inventory control with known demand. And now we are going to start chapter 5, which is about inventory control with uncertain demand. Okay, so let's start. So section 1 of this chapter will be about having an introduction to uncertainty in inventory control problems and the very well known inventory control model, which is the news vendor model. So we'll have the news vendor model at first, and then we'll see what if we have a starting inventory, how should we implement news vendor solution, and also what if we have multiple periods, then how can we apply news vendor model. So this is the agenda of this section. As an introduction to uncertainty in inventory control problems, let's see what are the sources for uncertainty in inventory control problems. As you remember in chapter 4, we assume that we know the annual demand with certainty, right? But we know that it's not going to happen in most cases in the real world. So we have uncertainty in annual demand because of several parameters like changing in customer preferences, right? Customer preferences can be changed over time. And because of that, trends can be changed in the market as well. And the availability and also the cost of resources like the materials or labor can be changed over time as well. And the vendor resupply times are not constant. They can be changed over time because of many reasons. Or weather and its ramifications. Yeah, I mean, one parameter that can affect the resupply times, I mean, the delivery times from the suppliers is the weather condition, right? And also changes in financial variables like stock prices and interest rate can affect our supply as well, and demand for products and services again can be changed over time. So yeah, because of all these reasons, we know that we will have uncertainty in demand in the real world in most cases. If we have a contract and that's firm, if we have a firm contract with the company to provide them a certain amount of goods, so that's constant. We can rely on the EOQ models that we have learned in chapter 4. But if that's not the case, we don't have contract, we don't have a firm contract, so yeah, demand can be changed, and we have to consider the uncertain inventory control models. Okay. Even if we don't have a firm contract and the demand, we know that the demand is uncertain, but still we can use the chapter 4 models, I mean the EOQ models, if the variance of the demand is low relative to the mean. So in that case, again, the EOQ models can be a good approximation for our case. And again, even if we cannot use the EOQ, but still the basis of understanding, I mean, the fundamental trade-off that we have there between the inventory holding cost and inventory ordering cost. So we do a trade-off, right, between these two costs in order to obtain the optimal order quantity, right? So that base can be used here for uncertain models as well. So it worth it. I mean, learning chapter 4 is so good. I mean, we can't say that, oh yeah, because of the uncertainty in the real world, so why we are going to learn chapter 4? That's not good. I mean, it's not applicable in the real world, so why we are learning that? So you see that it is, it's worth it. I mean, it can be a good approximation, or as I said, if we have contract, then the demand is deterministic, or at least it can be good for understanding the fundamental trade-offs for obtaining the optimal solution. Okay. The nature of uncertainty here, usually we formulated the demand as this form. I mean, we will have two terms. The first term will be the deterministic part of the demand, and the second term will be the random part of the demand. So, for example, we say that we have a mu as, let's say, the mean of the demand, and then it will be a variable around the mu with, let's say, mu plus, let's say, 2 sigma, and mu minus 2 sigma, for example, right? And here the sigma is standard deviation, right? Standard deviation. So as you see here, we have a deterministic part and we have a random part. Okay, so if the random part is too small compared to the deterministic part, then we can ignore the uncertainty and we can use the chapter 4 models as a very good approximation for our solution. But if not, we have to consider the uncertainty in our models. And here we assume that we know the probability distribution of the demand as the CDF, or cumulative probability distribution, FT, or it's PDF, I mean probability density function. Okay. Let's have an example here. The weekly demand. So the weekly demand of a news vendor over a year, so 52 weeks. So yeah, let's assume that we have recorded the actual demand for weekly demand of a news vendor over a year now, and now we do have 52 data here. So here we assume that this is based on actual sales and actual unsatisfied demand, because if we just consider the sale, so we are not actually recording the actual demand, because we may have stock out situation. So we had some demand, but we didn't have newspaper to satisfy those demands. So we do have unsatisfied demand, right? So here we are considering all of them. So this is the demand, not just the sale data. Okay. And as you see here, the variation is considerable, right? As you see here, we have 15, then 19, 9, 12, and so on. So as you see here, yeah, I mean, the variation on weekly demand is considerable, and we can't ignore uncertainty in this problem by having a very rough visual evaluation. But let's go ahead and have, I mean, the histogram to see how it looks like. I mean, how is the uncertainty in this data set. Okay. So this is the histogram of the data set that we have, and as you see here, yeah, approximately we can say it's looks like a normal distribution. Okay, so yeah, I mean, we can approximate the demand of this newspaper on weekly basis as a normal distribution. So to wrap up the introduction on uncertainty, we can't actually ignore the uncertainty models when the random part in the demand is too significant. So yes, we have to go with the uncertain models. And also the expected demand per unit time is relatively constant. So yes, I mean, the mu, the expected, should be constant, relatively constant. And the problem structure is not too complex. So in these cases, I mean, with these assumptions, we can use the techniques and the models that we are going to learn in this chapter. So let's see if we have an uncertain model what should be the optimization criterion in that model. So in inventory control problem, since we are assuming that demand is a random variable demand, then the cost function, as you remember in chapter 4, we had a cost function, right? A total cost function, I mean average total cost function per year. And then we wanted to minimize that cost function, right? And to do so, we took the first derivative of the total cost function with respect to Q, and then set it that to be 0. And then by solving that equation, we obtained the optimal value for order quantity, right? So same as there, here we need to have a cost function as well. And here, since the demand is a random variable, then the cost function will become a random variable as well, right? So we can't actually minimize a random variable, right? It's impossible. So in order to handle this, we need to consider minimizing the expected cost, right? So we will take the expected value of the cost function, and then we will minimize that expected function. So in order to justify this approach here, since we assume that the business that we are considering for optimization is a business that is in market for a very long term, so because of that, the inventory planning will be an ongoing process in that business for a long term. So because of that, assuming the expected cost is totally justified. Okay. But if we have a case that a product is purchased just for one time, and in that case, since it's not an ongoing process in that business, so it's unclear that how we can use the expected value. So yeah, in these cases, if it's for one time or for a very short time, then we can't consider the expected value because the error there will be significant. So yeah, in order to have a very minimum error, we need to consider the expected cost of function for a long term, not for a very short term or just for one time. So in these cases, minimizing or maximizing the probability of some events, such as satisfying a proportion of the demand, could be a better criterion. Okay. The types of the models that we have in uncertain environment can be categorized in these three categories: continuous review models, periodic review models, and single period models. In continuous review models, we assume that the inventory level is monitored continuously over time. So whenever it reaches to a certain level, we will place a new order. This is exactly the case that we had in EOQ models in chapter 4. As you remember, over there we assume that we are monitoring the inventory level over time, and whenever it reaches to a certain level, I mean that reorder point, we place a new order, and that's the case here as well. And it can be applicable like in the retail stores, as you see that in the cashier. They have an information system. They scan the goods that are sold to customers. So, I mean, on a real-time basis, the inventory level can be updated. So we can say, yes, actually, we are monitoring the inventory level in continuous fashion. So, yeah, for those cases, we will consider continuous review models. For the periodic review models, we assume that we are not actually monitoring the inventory level over time continuously, so we don't know what the exact level of inventory is at any time, but in certain discrete points in time, we will check the inventory level, and in that time, we will decide if to place a new order or not. And the third category is a single period model. So here we assume that we just have a single period, and we will place our order at the beginning or prior at the beginning of the period, and then by that quantity we will manage our sale over the period. So we assume that there is no chance to place a new order during the period. So we will have just one order for each period, and it will be at the beginning or prior the beginning of the period. And the single period model can be applied for the products like the fashion items, for example, the seasonal items, the fashion items. So they have a very short period for sale, and we need to order those fashion goods or seasonal goods prior the season or at the beginning of the season, and then we will manage our sale over the season, over that period. Or for example, or the food products that perish quickly, right? Or any item that has a short useful life, like newspapers. So for these goods, for these products, we can apply the single period model, which is our first model in this chapter, which is called newspaper or news vendor model. So in the next part, you will start the news vendor model. Okay, thank you.